This is video 2 in our series of notes on factoring. In this video, we're going to look at factoring trinomials using a method called guess and check. Now, trinomial is just a polynomial with 3 terms. And there's a lot of different ways that you can factor these, a lot of different methods out there. Guess and check is what I prefer because it's going to be the fastest and it's going to get you the most efficient results. However, any method that you learn for these, you're going to have to practice these problems. So I will be doing one example in this video and several examples in the additional examples videos that you can also find on this playlist. However, you're going to need to work through lots of these problems on your own to get good at this, get quick at it. I'll take you through the basic idea of it here. It's kind of like FOIL in reverse. So, in FOIL, you've got a first term and a first term, and those 2 first terms are going to multiply together. Well, in factoring, you're going to start out with a trinomial, and the first term of that trinomial must come from the multiplication of those 2 first terms in your factors. So in other words, whatever you choose to be your first term in your first term, those things must multiply to give you your first term in your original trinomial. Likewise, last times last should always multiply together to give you the last term in your trinomial. And the O and the I in FOIL will come from the inside terms and the outside terms. And when you multiply those 2 things together, get your results and combine those results, that should give you the middle term in your trinomial. So I'm going to go through one example here of guess and check. And then I'm going to give you some sort of more advanced hints that you can use to maybe make this process a little bit simpler. So I'm going to look at this, and I know that I'm going to hope that it factors into a couple of binomials. And I'm going to think about my first term here and first term here. Now those are going to have to multiply to give me k squared. I like to list my possible factors. The only way I could get k squared is going to be k times k. So for this one, that's pretty easy. There's no guessing involved. However, there are multiple ways that I can come up with this 50. And remember that my last term times my last term is going to have to give me that 50. Now, I'm ignoring the negative on that for right now. I'm just going to list all the ways that I can multiply integers together to get 50. That would be 1 times 50, 2 times 25, and 5 times 10. So those are my options there to get 50. So what I'm going to do now is I'm going to guess one of those pairs. I'm going to guess the 1 and the 50 because that's what came first. So we'll guess those, and we're going to check to see if that is correct. So to do the check, we need to do the O and the I part of foiling. 1 times k is 1k. 50 times k is 50k. And what we need to do is we need to ask ourselves, can we combine together a 1k and a 50k in any way using positives and negatives to make it into a positive 5k? So for example, I could put positives on both of them and get 51k, or negatives on both of them and get negative 51k, or a positive on one and a negative on the other and get 49k, or negative 49k, but there is no way that I can put positives and negatives on a 1k and a 50k to get 5k, which means those are not correct. So we guessed incorrectly when I guessed the 50 and the 1. So let's go back and try one of our other options. Now, oftentimes you would then flip the 50 and the 1 around and try them in the opposite position. However, since both factors just simply have a k in them, that's really pretty much the exact same thing that we just did, and there's really no point in trying that. So we've eliminated 1 and 50. Let's try 2 and 25. If I do my check here, I've got 2 times k, which is 2k, k times 25, which is 25k. And I'm asking myself, can I combine those together to get a positive 5k? And again, no matter how I put positives and negatives on the 2 and the 25k, we are not going to get them to turn into a 5k. So we have guessed incorrectly again. All right, so 2 and 25 are out, and I could try the 25 here and the 2 here. However, that's identical to what we just tried, so really no point in doing that. Let's try the 5 and the 10. This will be our last resort. If this doesn't work, then this thing doesn't factor. We'll do our check. 5 times k is 5k. 10 times k is 10k. Is there any way I can put positives or negatives on there to get a positive 5k? And the answer this time is yes. I would want my 5k to be negative, my 10k to be positive. If I combine those together, that would give me that positive 5k that we're looking for right here. All right, so let's look at our signs then. If I want this to be a negative 5k, then we're going to need a negative 5 there. If I want this to be a positive 10k, I'm going to need a positive 10 there. So we can do a quick check here at the end and make sure everything's working out. K times k gives us k squared. Negative 5 times positive 10 does give us the negative 50 that we need there. And we've already checked the middle term, so I'm feeling pretty confident. Final answer here, we've got k minus 5 and k plus 10. All right, some advanced tips for you on factoring trinomials. Now, there's lots of little hints and shortcuts that I could give you. These are the two that are probably going to save you the most time and result in the least amount of confusion. But if you need to go ahead and practice some basic problems and come back to this later on, if you feel like you're confused enough, feel free to do that. The first hint that I'm going to give you is if you are ever factoring a trinomial and you notice that your first and your last terms are both perfect squares, then I would encourage you, before you try anything else, to try the square roots that would give you those perfect squares. For example, 25x squared we could get from 5x times 5x, and 9 we could get from 3 times 3. Go ahead and give that a shot and see if that'll work. If we try our little check right here, we're going to see a 15x and a 15x, which would combine to give us the 30x that we want, and it works out. Now, this is not guaranteed to work. However, these so-called perfect square trinomials come up enough that if you ever do happen to see, a perfect square in the front and back of a trinomial, it's worth checking to see if that works. All right, the second hint that I will give you involves GCFs and common factors. So if you look at a trinomial, and if it starts out without a common factor, and it always should, because common factor you should be factoring out before you do anything else anyways. So if I look at this, and this doesn't have a common factor, and this one doesn't, that means that when I go to check when I go to create my factors for my binomials, the binomials cannot have a common factor either. Let me show you what I mean here. I'm trying to get 12x squared. I've already listed out my possibilities. So one of the ways I could get that would be 1x and 12x. All right, so I might go ahead and start working with these different options for the 6. We could get a 6 from a 1 and a 6. Now, I'm not even going to bother checking this because of this rule here, which states, if this original trinomial did not have a common factor, and it didn't, then neither of these can have a common factor either. And I noticed that 12x and 6 are both divisible by, well, 6 or 2 or 3. They've got lots of common factors. So this is not going to work. Now, I could change the position of the 6 and the 12, or 6 and the 1, and we could try this. Now, in this case, the 12x and the 1 do not have any common factors aside from 1. So we could try this, and we'd give it a shot. We'd do 6 times 12x to get 72x, and 1 times x to get 1x, and find very quickly that there's no way those are going to add or subtract to give us that negative x that we want. So we might go ahead and eliminate that possibility. So I might try them with the 2 and the 3. But again, there's no point in even testing this because 12x and 3 have a common factor. They're both divisible by 3. Maybe I'd flip it around, try the 3 here and the 2 there. Once again, though, 12x and 2 have a common factor. That's 2, so there's no point in checking that. So we've tried every possibility we could with the 1x and the 12x. Let's try the 2x and the 6x. We'll try it with the 1 and the 6 first. Again, no point in checking because 6x and 6 have a common factor of 6, and 2, and 3. We could try flipping them around and putting the 6 here and the 1 here. There's no point in trying this either, though, because 2x and 6 are both divisible by 2. So the rule eliminates that possibility as well. We could try the 2 and the 3, but we've got common factors in both of these now, so no point there. Or we could flip it around, try the 3 and the 2, but again, 6x and 2 have a common factor of 2, so there's no point in doing that. So we've tried every possible combination with the 2x and the 6x. Moving on to 3x and 4x. Let's try it with the 1 and the 6. No point in trying because of the common factor of 2 here. We could try the 6 here and the 1 here. But again, no point in trying because there's a common factor of 3 here. We've exhausted 1 and 6. Let's try 2 and 3. And here's one that's worth trying. There are no common factors here, so we'll go give this a shot. 2 times 4x is 8x. 3 times 3x is 9x. Anyway, we can change some signs on there to make that work. And yes, looks like we can. If I make this a positive 8x and a negative 9x, then we can go ahead and that should work out. So the point here is that you can oftentimes get away without having to check a whole bunch of things if you keep this rule in mind. That when you create these factors on the inside, if your original polynomial did not have a common factor, those two factors, neither of those two factors can as well. Again, you can find some additional examples of factoring trinomials in the later videos. Thanks.